Okay, good morning, everyone. We're going to get started now. So this is part 2 of a 2-part series, and I'm going to be talking about remote sensing methods, spectral analysis, and material identification. And today is going to be particularly focused on using the EZ-ID tool and all of the streamlined tools that you can use for data analysis, both in the field and in the lab. So thank you very much for coming today, and we'll get started. So to start off, I'll be introducing spectral evolution. So spectral evolution has been around for 21 years now. It's the leading manufacturer of UV-Vis NAR spectrometers and spectroradiometers. And we're located in Haverhill, Massachusetts, so the Boston area in Massachusetts. So our primary applications are in hyperspectral applications, remote sensing and vegetation, mining and geology, as well as photonics and calibration transfer. We have several different applications in all of these categories, and we're widely used in various industries. So today, like I said, we're going to be talking about the toolkit in the EZ-ID. And so I'll start off by introducing all of the tools, and then I'll do a demonstration on how I might identify some minerals and compare to spectral libraries. So EZ-ID as a whole is designed for robust spectral matching analysis while in the field and in the lab. So all of the tools are meant to streamline your research and compare collected spectra to library spectra. So this can be taken with one of our instruments or taken from an open source library or some of the libraries that we sell as well. So this tool, the EZ-ID tool, also allows you to create your own custom libraries for specific applications. And it is an additional software. It does not come with the instrument, but it's an additional software, but it's a one-time purchase, and all of our instruments come with a 30-day trial for the EZ-ID tool. So in order to access EZ-ID, there's a simple drop-down menu within DARWin that will give you two options, match analysis or library builder. So these are the two different things that you can do in EZ-ID. You can also right-click on spectra and send it to either of these two things. So if you're looking at a multi-measurement window, you can highlight the scans in that window and send it to EZ-ID or the library builder. And I'll go into more detail on how to do that, and I'll do it in the demonstration as well. So the first thing I'll cover is the library builder. This is a simpler tool than the match analysis tool, and it also, comes first. You build a library, then you can compare to it in the EZ-ID tool. So here I have the first window that pops up when you click on the library building tool. And so in order to use it, you need to load files into it. So you just select File, and it will give you this drop-down menu. And then you can select from SED files or ASD files or load other libraries into it to start with that as well. And then you save it as a library file, and you can access it later on. And so there's several different things that you can do. Once you collect scans, it will automatically input all of the metadata that was collected with it. So these are these columns in the bottom part. But you can also edit and change them for specific metadata. So you can add descriptions, You can do classes and subclasses, formulas of different minerals that you've scanned, and things like that, or different biomass if you're doing speciation. Using this tool, that's something that can be very useful as well. So now that you've created a library file, you can access it in the EZ-ID Match Analysis software. So this is the window that opens up when you've never used EZ-ID. So as you can see, it's a blank screen, but on the top left, you have the file and the tools drop-down menu. And in that white box right underneath there, you'll be able to see all of your collected spectra that's loaded into EZ-ID. On the right in that gray box, once you load a library, that's where you can access all of the library scans. And in the bottom left, we have a smaller window. Oh, I guess in the middle, you have the graph of where you'll see the spectra, and that can be represented in several different ways. And in the bottom left, you have a window that has match regions, display, how do you want to display your spectra? So it says display original spectra because that's the default. And then it has a scan window in that bottom left window. And on the bottom right is going to be our match analysis results. And we can create more windows. And I'll get into more detail on that. And then on the right there, we do have mineral scalars, and we'll talk about that as well. But the first thing you need to do when you open EZ-ID is select a library. So this can be from your files, a created library file. So you would do load EZ-ID library file and access it there. Or you can use our built-in libraries. So EZ-ID will come with the USGS V7 spectral library. That's a common open source spectral library that people use. But we also have, for additional purchase, we have a SpecMan library created by Spectral International Inc. This is commonly used for exploration geology, and we also have a GeoSpec high-resolution spectral library, which is created using our highest resolution instruments on different mineral libraries that we've gotten access to. So those are collected high-resolution libraries. So the next thing I'll talk about, once you've loaded in your library and you've collected scans, is the automatic mineral scalars. So this will be collected or automatically generated when you load in a scan. So these are numerical values that indicate spectral shifts in a mineral signature. These are used for spectral geology, identifying crystallinity, alterations, and geochemical conditions. For example, the KCl scalar provides an indication of a kaolin group of minerals, and all mineral scalars all of these results are stored in an EZ-ID log. So every time you select it, it will be stored within a file folder and in a file for your session. And you can access that at any time within the spectral evolution folder that's generated when you take scans. So there's no need to actively document any of these results. They will be automatically collected and you can access them afterwards. So this will further streamline your analysis. So this is what those automatic results look like. So I had a session where I scanned 4 different samples, one of which was a white plate. So it had very few or no features on it. So it doesn't actually get any features or results from that. So it's able to identify that's not a valid response for these different scalars. And the other 3 are different minerals that may or may not have features for each of these scalars. So That's why you'll see blank boxes for if there's no feature there. But because this is all collected automatically, it makes data collection a breeze. And we also have a batch analysis tool, which will allow you to set different parameters within EZ-ID and then analyze dozens of scans all at the same time and get your results in an Excel file, which is really convenient. So here, this is where you would access the batch analysis. So there's 3 buttons below your scan window, and that's select all, setup file, and then batch process. I believe when you don't have anything highlighted, it will just say single process. And then when you highlight several, it will say batch process. But this is where you would set up a batch analysis on several scans, so you don't have to click through each of them and record anything and see what they identify as. So here at number 1, so this is where you set up the file. This is the window in the bottom left. 1 is click to add a single match region. So this is where you could manually input different match regions. 2 is copy the regions that you were using in your analysis. So that's the most convenient one. So that will grab the bounds of the match regions that you're using. And then 3 is adding columns for different statistical analysis. So you can analyze data in several different ways all at the same time and get the results. So you could do first derivative analysis, full spectrum, or Hull quotient all at the same time. So it's very convenient. And then these are the match regions that I'm talking about. So adding and manipulating these match regions. So when you load in spectra, the blue line is going to be your sample, and the red line is going to be whatever it's matching most directly to within your spectral library. So your analysis is always only going to be as robust as the library that you're comparing to. But like I said, you can create your own libraries and add to libraries to make it more robust. So like I said, the blue line, which is the test spectrum, will be named with the blue font above the graph. And the red line is the library spectrum, which is in the red font, and it will give you a correlation, the best match that is happening there. And in the bottom right, or actually to the right of that, you'll see all of the mineral scalars being recorded there. Like I said, these will also be recorded in that separate file. So when you're in this window, you can grab and slide around these green match regions. And so what it's doing is it allows you to select certain features that you know are relevant to the mineral and the mineral's identification. So you can create those regions so that you're only processing the data that's in those regions. So if you have something optically complex, this will allow you to decompose that spectral signature. And especially if you have something that you know its features and you know that you're looking for something more fine in the spectrum, then you can ignore certain features that you know are only relevant to that mineral or the matrix that you're trying to ignore. So that allows you to play with this and kind of identify what different regions you want to focus on. And then once you've identified the regions that you want to focus on, you can do a batch process where you can grab all of the regions that you have highlighted and do analysis on hundreds of different scans. So that'll streamline things. So just right-clicking on the graph will allow you to create a new region, and you can expand them. And I'll show you that in more detail when I do the the live demo. In the bottom right, we also have the match region scores, match scores. So for this, you can select what kind of statistical analysis you want it to be recording. And you can select a subset of your match regions. So if you want to have several windows that are reporting just the A region or just the B region, or if you had a third, like a combination of those three, you can do that live and it will give you its best result with all of those. So you can really analyze it in several different ways all at the same time. And then there's some additional tools that may come up. So you can operate the instrument within the EZ-ID tool set here. So you have a reference and target button under the bottom left. So there's the match regions tab, which will show you what are my match regions, what wavelength ranges are they. There's the display, which will allow you to select, do I want to look at it in derivative format or something else, or original spectra. And then there's the scan tab, which will give you the reference and the target button. So you never have to go back into DARWin if you don't want to. You can operate the instrument and quickly take scans and analyze them all in the same window. And we do have an extra tool, the Munsell Rock color match, which will just give you a color estimate or a color analysis on the rock, which isn't always great for mineral identification, but it is there for your convenience. And so now I'm going to switch over to doing a live demonstration of just some of these tools and how I would identify minerals using them. Okay, so we'll just switch over here. And then once I do that, we can open it up to questions. So here I've launched and connected, which in the last video, I went over how to connect to the instrument and how to take scans. So now I'm following up on that to show how to use the EZ-ID tool. So I've already connected to the instrument, and now I'm in this window. And so I'll start off by, I've already taken a reference scan. I'm just going to take a few target scans of 3 different minerals. So I have a rhodochrosite mineral here, lepidolite, and then just a piece of sandstone. So I've already taken a reference, and now I select target to take the target scan. And so it plots on here. So I opened up a multi-plot so that I can see them all on top of each other. And just to show you, when I took that scan, it automatically populated an EZ-ID because I had it open. So I'm taking the scan of the next mineral, which is lepidolite. I'm doing this with a contact probe as well. And now I'll take a scan of my sandstone. And so there's our sandstone. And so now that I've taken these scans and plotted them, I can select them over here in the legend and right click, and it will give me a drop down, just so you can see it because it popped off the screen. I can go to the EZ-ID library builder, so I can send these scans to the library builder. So I can do that here. And now it's populated this library with those 3 scans. So I could say rhodochrosite. Oh, I don't have my. So I can name them here. I can fill in GPS coordinates, location, description, environment, and then the source library if I was using something external. But there's a large array of different things in here, and you can change what is going to be populating in here. So you can add or subtract these off so that you have less columns, but I added them all in for our convenience to look at them, but you can create a lot of different fields and custom fields here as well. So it's an easy to use and pretty robust tool. And then up here, you can load in already scanned files. So this is where you would go in and select the SED files that you want, and then save to a library file here. So I'm just going to close that. So I created a test library yesterday, which is the same rocks. But I'm going to send this over to the EZ-ID match analysis window, even though I already have them in there. That's how I would do it. And since it is already in there, it knows that the spectra is the same. So it doesn't actually duplicate anything. So we can look at these 3 here. So with the first one, I'll just remove any regions that I had here. The first thing that I would do is select a built-in library, and I'm going to grab the Spectral Library version 7 because it's very commonly used. And I know I'm looking at minerals, so I'll select the mineral subset of this library. And so as we can see, the rhodochrosite is identifying correctly with just the raw spectra. The lepidolite is also at 0.980, and the sandstone is obviously not identifying correctly because this is a mixture. But say I wanted to get more refined, I can grab a feature that I know is present, like kaolinite, which is almost certainly in the sandstone, and identify some of the minerals that are in there. So I can add these match regions, I can slide them around or expand them, and then I can also have different statistical analysis going on down here. So right here I have it's grabbing the A and B region, and it's doing a logarithmic Hull quotient here. So it's identifying kaolinite at 0.946, so that's a pretty robust match. The match regions, so the full spectra with no match regions doing logarithmic Hull quotient is actually identifying as microcline. And then no regions, full spectra should be the so yeah, so basically you can create several different match regions and identify different mixtures of match regions in here all at the same time. And if I wanted to create a new score table, I get this window, so I could say I want to do just the A region in a convex Hull quotient, and I want it to be logarithmic. And then it would create that region here and give me an analysis. So you can have several different windows. I can remove these or edit them and change them. And so you can do that all within this window. You also get a few other tabs and tools to use. So this is the comparison plot tab here. So this is this window where you can move around these match regions. But I can also select the information and give me the information on the spectra that it's matched to here. So that's convenient that you can see the metadata from your library on how that scan was collected. The USGS V7 library is very good about having detailed information on all of your scans. So if you do match to something that's weird, you may go in here and see that they're using a very coarse resolution instrument, or they grabbed spectra from a different kind of medium. So this is important information to understand if you're using libraries that you didn't create yourself, to see some of the information that you're matching to, so you can be confident in the match that you got. But it's very easy to analyze the data in several different ways in this window. So we're doing very quick statistical analysis here. And then on the right here, when I click through these, as you can see, the mineral scalars are going to be reported over here, and they'll quickly change and give you that data in real time, which is very useful. You also have the toolbox up here. You can display it in tablet mode. This will make the font size a little bit bigger. For anyone that likes larger font sizes, this is very convenient. And then there's a few tools here, like adding a match region you can do up here instead, which you just give it the wavelengths, which is a bit redundant, but it's there for your convenience. And then we have, this is where you access the Munsell rock color match, which you can cycle through these and it will automatically identify what color it is based on that. So it's pretty convenient. So now that I've done that, I'm just going to quickly select all, set up file, open up this window. And so I want this one to be original spectra, first derivative, and then log Hull quotient. And I'm going to grab the match regions that were on here, and there's a few from the last. And then I'm going to grab the top 3 results, and it will grab the highest performing results. And then by selecting this, you can create another column where I could then have normalized Hull quotient here as well. And then I can click these boxes to say I want a subset of these match regions. So I can do a random, hit OK, and then batch analysis, and then it will ask you where you want it to save. So I'll save it into today. And then I'm just going into my files. So we have the spectral evolution file. I'm using 94D6, today's date, and then I have this test file. And so it does look a little crazy just because the names are a bit long, but it will be reported right afterward, the highest match. So these are all reported here. So I got the 0.990 R squared. And yeah, it will give you the best result right along this line, and they're column or comma separated. So it's quick and easy analysis. And also in here, in this EZ-ID file that's created when you're using EZ-ID, it will have the mineral scalar log. So this is from today. And so I have those 3 scans and then the mineral scalars that it's created and generated. And so if I was using a shorter naming convention, it is very convenient. So you can see the names right away. So yeah, that's a quick rundown of how to use EZ-ID. I appreciate your time, and I'd be happy to answer any questions. But thank you very much.